So hi guys, today we'll be discussing the round C of Codejam of Google. So I solved the first two problems that were game sort and immunization operation. So these were from round C. So I'll be discussing both of these problems in detail. These are good problems. It's not particularly something that involves complex data structure. So first one is based on greedy approach, and the second one is a simple optimization problem which you can easily do if you are comfortable with maps and other kind of data structures. Cool. So let's get started with the very first problem. So the problem states that Amir and Badiri are playing a sorting game. The game starts with the string s and an integer p. So let me just give you the gist of it rather than going through the entire problem statement. So what the problem asks us to do is that you'll be given some code segments of strings, right? So over here, for example, you are given three code segments. Then what you are allowed to do is that you can permute these code segments individually. So you can make OC or CO out of this CO, right? So you can permute the individual characters in each segment. After that, after each of these operations, what you need to do is that after like you're done with your operation, this entire string, right, or entire collection of strings should be sorted lexicographically. So that is what we wanted to do. If there's a permutation possible for this, then we had to print possible and followed by the permutation. If it's not possible, then we simply had to print impossible over here. So guys, any doubts in this? All good? The problem statement is clear, I guess. Cool, I'm gonna move ahead now. Okay, cool. So how will we do this? So this is a greedy question, right? So what I can say is that firstly, let's just take the string from the user, right? So I'll be taking the string, and then what I want to do. So I want to make the current string as low as possible because I'm already moving from left to right, correct? So what I want to do is that if I have a string, so let me just give you an example. So let's say I currently have a string CO, right? Okay, let's change the color. Oh, CO. So I have the option of keeping it as CO or making it OC, right? Since it's the very first string, so obviously it makes sense to keep it the smallest, right? Because when we are moving from left to right, let's say I already processed maybe X strings are processed, and I currently am at a string Y, let's say, right? So being at string Y, what I want to do is that I want to make Y greater than X or greater than all the strings that were over here. Or I can say, since these are also lexicographically sorted, so I just want to make a Y greater than the last string. So I'll make Y greater than the last string, but that should be the smallest among all the possibilities. For example, let's say my previous string is ABC and my current options of this string is ABC as well, right? So I can either keep it equal because they have said that we have to make the non-decreasing order. It's not like it has to be strictly increasing, correct? But now let's say I had a string ABC in the past, and now I have a string DAB, right? Okay, DAB. Now obviously DAB is greater than ABC, but technically I don't want this kind of a greater string. I just want this string or this particular string right over here to be just greater than ABC, right? So what's the smallest string that is still greater than ABC? So I can write DAB as ABD, right? And this would still be greater than ABC. So I'll be doing this. As soon as I do this, I'll be getting a string that is greater than the last string, but is still the smallest. So this is the operation I have to focus on. If I'm able to make all the strings in this fashion, then a valid answer exists. Otherwise it doesn't. So that is what we have coded. So let me show you the code as well. So what we're doing is, okay, over here. So we are taking all the strings, right? And I've also defined the operation OK, or you can say valid, whatever you want to call it. OK is actually the smallest variable you can write because it's just O and K. So yeah, OK is equal to true. And in case I detect that okay, like this particular variable was already invalidated, that means in some operations to my left, right, or in some of the strings that were to my left, it already happened that I was not able to come up with a valid permutation. So in that case, answer definitely does not exist, right? So I'll continue over here. There's no point in building the string further because I already know that the string wasn't possible, or the current inputs that are being provided to me are incompatible to get a valid answer. So if this is the case, I'm already continuing it, At the end also you can see that I'm checking if the this particular variable is set to false. In that case the answer is impossible, or if it's set to true, then only the answer is possible, and I'm gonna print the result whatever I have. Now let's come to the part wherein we have to make the string as small as possible, right? So what can I do? What I can do is that I can say that okay, if it's the very first string, right? Very first string. Okay, if it's the very first string, then I want to make it as small as possible. So I'll just sort it. So sorting is definitely one of the ways to make it as small as possible, right? So I'll sort it. Else I'll say, okay, else what I'll do is, and then I'll store this particular string into the result variable, and I'll set my last to s. Now what is last? As I told you, I want to keep a track of the last string that I've processed. So that is being stored in last. Okay, last string processed. So if I'm at a iteration I right now, I'm gonna move to the iteration I plus 1, and in that iteration I want to know which was the last string I already processed. That's why I'm keeping this last variable with me. If this is not the case, if I is not equal to 0, that certainly means I've already processed some strings, right? In that kind of a scenario, I need to do some operations, obviously. What kind of operations that would be? So now I want to make the current string just greater than or equal to, so just greater than or equal to the last string. So for that I have defined an operation get next. What I'm gonna do is, firstly I'll only take the frequency of all the characters, because that's what is required. I can make any permutation. So in order to make any permutation, you can either use that do while permutation thing, and you can have an n factorial logic, which would definitely fail, right? Or other than that, you can say that I'm gonna take the characters frequency, and then I'm gonna build the string as I want. So this is the get next method that provides me with the string. After that, I check that if the current dot size is not equal to s dot size, then certainly something happened because of which my answer isn't valid. In that case, I will set OK to false. OK to false basically means that you got a wrong answer, right? I'll set my last to car. This is something I actually forgot to do, and that's why I got 2 wrong answers. Else my rank could have been better. Okay, so what you will do is that you will say last is equal to car. So I already got an answer, and in the next iteration, this is going to be the last string I processed. So let's set it to it, and then I'm going to push it to my result vector. Cool. Now let's look at this particular function, that is get next. Now what is even doing? So firstly, it's checking that if your I is basically the index you're currently at. If your I is equal to b dot size. Now what's b? B is actually the last string you processed, right? Okay, let me just write it in a comment over here so that it's easy to understand. B is equal to last. Right. Okay, let me just zoom in the code a bit. Okay, if b is equal to like over here, b is equal to last. If I'm checking if I've already processed the entire b string, that basically means that all the 2 strings was exactly similar. So this is a scenario wherein, give me a second, I'll just explain that. Okay, so this is a scenario wherein the string A was ABC and the string B was ABCDEF, right? So you started processing it, you process this entire string, that is the last, or B as we called it, and you also process this much, right? So this much string has already been built. Now you're saying that you have already already traversed the entire string now. So you are at this particular position. Now what do you want to do? So you'll say, okay, whatever string is remaining now, right? This could have been Z, X, Y, or whatever you want, right? So whatever string is remaining, for this at least, I want the smallest possible combination. Now how do we get the smallest possible combination? We just sort it, right? So that's what we're going to do. So we're going to say if you're over here, then we're going to sort it, and then we're going to return it, right? Else, one case is that, okay, so let's say your string was ABC, as we said, and currently you are at I equal to 1 considering 0 based indexing. So basically you are at the character equal to B, right? So if you are at this particular character B, then in order to make a string that is either greater than you or just equal to you, you would like to have the character B in that string as well, right? So that's what you're going to do. You're going to say that if this character is actually 0, so if the frequency of B in the current string I'm trying to make, if that is 0, then there's no way I can use it, right? So if that is the case, then I'll have to use a bigger character than me. So I'll check for all the characters. Now this only 26 characters are there, so it won't actually increase my complexity by that much, right? So I'll check for all the characters that are actually after, okay, that are actually after this particular character. For all of these characters, I'll check that if it's possible to make a string. So now this scenario basically means Okay, I didn't get it. Okay, never mind. Yeah, over here. So this scenario basically means that currently you didn't have a B, and let's say you had a C. So the strings now you are making is AC. AC is definitely smaller than the previous string because your previous string was ABC, right? So after AC, you can append whatever you want, and still it would be smaller than the previous string. In order to make the answer best, or in order to make the answer smallest, it's always advisable to sort the remaining part and append it, right? So that's what I'm doing over here. What I'm doing is I'm saying that I'm gonna like append the remaining string in the sorted order, and then I'm gonna return it. Now, in case it never happened so that there was, let's say, no character that is appearing after B, right? There was no such character available. In that case, the answer definitely does not exist. So what would we do in that case? So we can return the entire string. Like we'll return a invalid string. Now you could ask me what is this? Like it's just gibberish. I just typed anything that came to my keyboard. So I just wanted a string that is of greater length than 100. So I just typed it, and this also is gibberish right over here. If this is not the case, so if this particular frequency is not equal to 0, that means there is some frequency, right? So if there is some frequency, in that case I can say that I'll make a string, right, considering that particular character. So I'll make a string res whose first character would be same, whose character would be same as B, right? And then I'm gonna say that I want to like build the remaining string out of this. So how would I build it? So I'm gonna recursively use the same function again, right? I'm gonna use this same function with the index incremented by 1. So over here I'm passing I plus 1, and then I'm gonna like over here what I'm doing is I was using the unordered map which contained the frequency. I have to decrease the frequency because I've already utilized one frequency for this, right? This operation, or adding it as the first element. Over here I'm again making the unordered map or frequency map valid. So these are the two things I can do. But over here it's also possible that it was not like I didn't get a valid string. How would I check it? So since these strings which I am providing for invalid inputs have a size greater than 100, so I can say if the size is greater than 100, then it's invalid, and I'll have to try the next best possible case. So next, how do I try the next best possible case? I'll just do exactly what I did over here. So it's exactly the same. Yeah, I know this is not a good coding practice. Had I been asked this question in an interview, I would definitely have used a different method and would have coded it up over there. But anyway, since it's a contest, I just copy pasted the code from here to here. And yeah, that is it for it. So that completes the question, and this is the valid solution for the first problem. Any doubts in this, guys? Guys, all good? Okay, I'm assuming that everything's fine and understandable. So moving on to the next question. Okay, so yeah, next question is immunization problem. So yeah, like the statement is pretty long. Let's not get into it. What the problem basically means is that let's say you have a robot, or you yourself are standing at the point 0, 0, right? And then from point 0, 0, you'll be given some instructions. So you will be told to move X points. Now these are the X points. So they can say that okay, you have to move X unit in the right direction or X unit in the left direction. These are the two kind of operations you can do, right? So that's fine. But then like what is the thing you want to do? So the thing that you want to perform is that there would be some pickup locations, and then there would be some drop locations. So these are the pickup locations that are defined in the very first line. So 121, 312, 271, these are the pickup locations, and these are the drop locations, right? So you can pick up the thing from anywhere you or like from these locations. So for example, in the very first scenario, as I said that initially you're standing at 0, 0. So standing at 0, 0, or standing at 0 basically, it's not a two-dimensional coordinate system, it's a single dimension or a single line. So standing at the position 0, I ask you to move 271 units to the right. As soon as you do it, which all points would you be covering? So definitely you will be covering the point 121, you will be covering 75, you will be covering 271, right? So these are the 3 points you will be covering. Now what you can do is, like let's say 121 definitely had some pickup, right, whose drop location is 199. So definitely 121 is coming before 199, right? So you can pick up the location thing at 121 and you can drop it down at 199. Let's look at the other number. So over here, it's saying that you can pick up the thing. So you are going up till 271. So definitely you can pick this up. but over here the drop location was actually before it, right? So you can't drop it over there. Now in the other scenario, anyway, didn't reach this, right? So no point in discussing this. And this point, in this for the fourth item, you definitely picked up the item at 75, but you were not able to drop it. The reason being the drop location was 368, and your end goal would be 271, right? So you won't be able to drop it, and then you will be performing these operations. So yeah, that's the question. The only problem with this is a very simple like implementation based problem. The only problem being that the constraints are such that you cannot actually you can't brute force it up, because you might say that okay, I'm gonna for each moves I'm gonna check for each of the indices. Yeah, you can do that, but then you're gonna get a TLD. So how do we optimize it? So there's a trick, there's a trick by which you can optimize it. I'm not saying this is the only possible solutions. There could be n number of solutions for this, but this is one of the solutions that is a bit harder to code, definitely, but it's definitely easy to understand as well. So yeah, the code is a bit long, maybe like a 60-70 line. Okay, I guess it's a more than 100 line code, but it's pretty easy to understand. So firstly, what I'm doing is I'm making my pickup locations, right? Okay, let's just remove drop because we're not using it. But anyway, so I'll say firstly they are providing me with pickup locations, right? And over here they had not clearly mentioned that whether two values could be same or not. At least I couldn't find it, even if they had mentioned it. But yeah, two values or two pickup values could be exactly same. How so? How would you deal with that? So in order to deal with that, what I did is that I made a map, and I didn't make a map of intent. I rather made it a map of vector int. So over here, I'll be able to store that at a particular value or at a particular location. So let's say at a particular location, maybe like 1 to 1, right? At a location 1 to 1, there are multiple pickups that are doable, right? So at 1 to 1, I'll write X, Y, Z, where X, Y, Z are the pickups that I need to do from the location 1 to 1. I'll be pushing that into the map. Now why I'm using a map? Because I want a sorted order so that I can easily traverse it, right? So for that reason, I'm using this map. After that, I have to take the drop locations. Now initially I did something different, so I'm not discussing that, but yeah, I'll be taking the drop locations, and what I'll be doing is I'll be making a map logs that basically means locations, right? Okay. Locations, and it would say that the location of the ith box or the drop location of the ith item is actually A. Right. This is the way I'm storing it. Cool. After that, I've made a multi-map. This is activated. This basically means that the ith box has been picked up. But wait, it has two things over here, right? Pair of intent it says. So basically, the box, the ith box. So the first thing is actually location, right? So it would say that a box at which needs to be dropped at this location has been picked up. And what are the details of this box? So yeah, it's the ith box, and it was picked up from a location, pickup location. So this is what pickup location. So this is what it is storing. Okay. Alright. After that, I'll get over here. I'm saying that the move can be of two types. Either they can be negative or they can be positive. Now, why do I need to explicitly state it? Because the thing is gonna change. So right now I'm actually having a multi-map. Now the way I'm gonna traverse my multi-map is gonna change based on whether my move is negative or positive. If my move is positive, and since you know that the maps are already sorted, right, in the ascending order or non-decreasing order, then in that case, if my moves are negative, in that case I'll have to go from the right to left. I'll have to decrement my pointer at each level, right? So that's the reason for making it this way. But anyway, so this is the entire code for negative, and this is the entire code for positive. I'll just be explaining it for positive, and you can you definitely know that it's the exact same thing with negative as well. So the only thing that would change is that you'll have to decrement this particular operator, and then the checking would actually be a bit different, because when you're moving from right to left, then either you check for R begin, or you have to check that if you have already reached the very first position, then you just iterate it once, right? So those things I'm assuming that if you're trying to solve this particular question, you already know. If you don't, then let me know. So I'm assuming these things are known, right? Do I need to explain these things? Okay, cool. Okay, so what I'll be doing is, let me just explain it for positive, because positive has less edge cases, right? Okay, it's for negative, this is for positive, right? So firstly, I'll be saying that it could be the case that in the previous iterations itself, I had picked up some boxes and I was not able to deliver it, right? Now, how can that happen? So that is easily understandable. So let's say my pickup location was 123 and my drop location was 124, and the number of steps or the last index I moved from left to right was 123 as well. Let's make it 130, and yeah. So so this is my pickup location, and let's say 100 to 120, 125 is what I traveled, and 130 is my drop location, right? So in this case, you went from 100 to 125, you definitely picked up the box, but you were not able to drop it. So in the next iteration, it's possible that you're gonna go from, let's say, 125 to maybe like 200. So when you'll be going from 125 to 200, 130 is gonna come in your route, right? So you already would be having a box. If that's the case, then it's you can just give it to the whosoever wants it, or you can drop the box at the drop location. So that's what we are gonna do. So we are gonna say that auto IT2 is equal to lower bound of cur. So the reason of taking the low bounds and all this stuff over here is because the number of points may be less. So it could be the case that your point in particular, point I, could be, let's say, 1e5, right? But the number of points in the activated multi-map or whatever data structure we have taken is gonna be less, right? So that's why I'm traversing this map, right? Rather, or this particular multi-map, and not the individual points per se, else we are gonna get a TLE. So I'm gonna say like I have to check the points that are coming after it. So I'll check if this is not the end of it, right? Then I'll traverse, and till the time I don't get this end, I'll keep traversing it. So this if statement can actually be removed, but I copy pasted the code from above for the if statement. Hence, there's a lot of clutter. Also, I need to check now that if the value currently which I'm standing at, if it's greater than the current position which I was standing at earlier, right, or which I terminated at my previous loop, plus the number of moves I'm allowed to travel. If it's greater than that, then I have to break, because this is the point where I cannot be standing, or this is the point where I cannot reach. True. If that's not the case, then I simply can erase this particular point, because I'll say I already dropped the box, so I don't need to know whether this particular position is valid or not. I just dropped the box over here that was required, right? And I'll increment 1 point further. Right? After that, what I'll say is that, okay, I already know that what all boxes were droppable. Now I need to check, I need to pick up the boxes that are also coming in my route, so I'll do that. So the logic is fairly simple. So I'll do the same thing, that I'm gonna go from cur to my cur plus move, and for all the boxes that are gonna come up in the pickup range or in this particular range, I'll pick those up. The way I'm gonna insert these boxes into the activated thing, so available is not required, because available we can get rid of that. We just need the activated side. So I'm gonna say whatever box, right, is there for this particular location. So this basically means, okay, so this vector basically contains the boxes which have been picked up, right. Basically in the question they had mentioned vaccines instead of boxes, but yeah, this is easier to explain, so I'm saying boxes. So yeah, whatever boxes have been picked up, we know about their identities. So we'll say that the box that needed to be placed at this particular location has been picked up, right? This is the ID of the box, and this is where this is the point from where I've picked it up. Now, why is this important? We'll explain that in like 10 seconds. Just hold on. Then I'll be putting all of these things into my activated multi-map. And then for each of these points, since I've already picked up the boxes, I'll erase them from the pickup map. And once we are done with this loop, so now we'll say that, okay, it's possible that while picking this up, so it could be the case that currently we are at maybe like 125, and we had to go up all the way to 200, right? So this is the pickup location, let's say, right? And the drop location is maybe like 170 or 180. So definitely after picking it up, I can drop it. So I have to check for all of these scenarios as well. So I'll be using the same limits, that is current till current plus move. But over here, I'm gonna check that whether this particular value, that is the place from where you picked a particular box, right? Yeah. If this particular value is less than or equal to the place at which you're gonna drop this box. So if this value is smaller than this particular value, only in that case it's possible for you to pick up the box and to drop the box in the very same move itself, right? So this is what I'm gonna check. So if this case is happening, only in that case I'm gonna increase the number of boxes I've dropped in this move, right? Or I've delivered in this move. I'm gonna like pop this element out, or you can say like I'm gonna remove this particular element, and then I'm gonna increase the iterator. Cool. After that, for each of these like moves, I'm gonna print the number of boxes I dropped. So that is C. Yeah, over here itself, and I'm gonna increment the current or the position I'm currently standing at. Right. So yeah, that's it for this question. Any doubts in this? Cool guys, I'm gonna close the stream now. I hope you understood the problem.